Hello, this is Psych, and welcome back to my channel. Today, I'm actually going to talk about something referred to as levels of measurement. If you look at various textbooks, you're going to find a definition of measurement that is something to the effect of measurement is defined as the systematic assignment of numbers to a variable according to a set of rules. This definition is actually a little bit controversial, and I can actually I'll address those controversies in a different video. But the concept of levels of measurement is still a useful concept, even if we happen to disagree with aspects of this definition. The main reason that it is a useful concept is because we use this to basically inform our analyses, and the types of analyses that we would conduct is informed by the way that we have assigned numbers to a variable. So today I'm going to talk about four different levels of measurement: nominal, ordinal, interval, and ratio. Nominal variables have the property of identity. In other words, in this case, I'm going to use numbers to categorize or classify objects or people or any kind of thing into a group that shares a characteristic. So let's consider the variable marital status. I could assign a number 1 to all people who are married. I could then assign a number 2 to all people who are single, and I will give a 3 to all people who are divorced. The number 1 is used to pick out all people who share a particular characteristic. In this case, the characteristic of being married, whereas the number 2 picks out all people who share a different characteristic, the characteristic of being single. The numbers really have no numerical meaning, and they're simply used as this kind of arbitrary signal or way to capture how we have categorized or grouped people into these different categories. Ordinal variables have the property of identity, but they're also going to have something else, the property of order. With ordinal variables, I can look at them and I can say something about one thing having more or less of something than a different thing. So let's look at a simple example that's commonly found in textbooks. 4 students are running a race. We can see that student A finished in 6 minutes, whereas student B finished in 5 minutes and let's say 59 seconds. Student C finished in 8 minutes, and student 4 finished in 9 minutes. If we make this data ordinal, we could rank the students according to who finished first. So we could have student A finishing first, B second, and so forth. All we know from these numbers is that person A was faster than person B, who was faster than person C, and so forth. We do not know how much faster person A was than person B. And we can see that the speed at which they completed the race, person A was very close to person B, whereas C and D were a bit further behind. So the rankings, the numbers themselves, don't tell us anything about the distance or the speed between each person. Only that one person was faster than another person. For this, if we want this kind of information, we need a variable that is interval. Interval variables have the property of identity, order, and equal magnitudes between each number. The most frequently discussed example in textbooks is temperature, measured in either Fahrenheit or Celsius. With this level of measurement, we can say that the distance between let's say 40 degrees and 30 degrees Celsius, is the same as the distance between 10 degrees and 20 degrees. The problem with Celsius, and I guess it's not really a problem, it's just kind of a limitation, is that the zero is arbitrary. In other words, the zero is not what we would call a true zero. A true zero would indicate nothing, right? So a true zero would actually indicate the absence of something. In Kelvin, the zero is actually a true zero because it indicates the absence of heat. Variables with the property of identity, order, equal magnitudes, and a true zero are referred to as ratio. So let's consider an example. The amount of money in my bank account. We can say that the amount of money an individual has in the bank has the following properties: identity, because each number is different; order, equal magnitude in a sense that the purchasing power, let's say, of $1 to $2 is the same as the purchasing power that you would get from $2 to $3, but it also has a true zero, because the zero would indicate the absence of something, in the sense that I don't have money. With ratio variables, we can also say something a bit different that we can't say with interval variables. With a ratio variable, I can say that 40 USD is twice the amount of 20 USD. Like I said, I can't make this claim with interval variables, such as what we would do with, say, Celsius. So let's look at why this may be, or why this is the case. You can see here a graph where we have one day it is 20 degrees and the second day it is 40 degrees. Why? If I look at this graph, it looks as though 40 degrees is twice as big as 20 degrees. So why is it incorrect for me to say that 40 is twice the amount of 20? And the reason has to do with this arbitrary zero. It's possible in Celsius to get negative degrees. So this zero here on my graph is really just an arbitrary number, and we really should extend this further. So what would happen if we put the same 2 days, but extend it all the way down to a true zero? We can see here that on a Celsius scale, that the true zero would be minus 273 degrees. And if we extend that all the way down to a true zero, it becomes quite obvious that 40 degrees is not twice as hot as 20 degrees. I want to, before I close this video, talk about one last example, just because it is it's very typical. When we are responding to a survey, we're often asked about the extent to which we agree or disagree with particular statements. So for example, you could have the statement, "I love math." You're going to have some people who say, "Yes, I strongly agree. I really love math." And then you're going to have other people who say, "I strongly disagree," and so forth. Well, when we're using these Likert-type scales, what should we think about their level of measurement? And one way to think about this is to ask a question, a very simple question, it seems. Is the amount of love that it takes for me to move from strongly disagree to disagree the same amount of love that it takes to move from disagree to neutral? Now, I think it's probably obvious that we don't know that, and there's no reason to think that the amount of love that it takes to move, to transition from one number to a different number, is the same across this scale. And if that is true, like I said, we simply just don't have any evidence of that. So it is best to treat and just assume that Likert-type scales are in fact ordinal. Now I'm going to leave you with one last tip. If you were ever given the choice, and when you're actually creating a survey, measure a variable on the highest level possible. So in other words, if you have a choice between measuring something as a ratio or as an ordinal variable, you should measure it as a ratio. The reason is that I can always turn something from a higher level of measurement, such as ratio, into a lower level of measurement. For example, if I have age in years and I have their actual, let's say, ages, then I can always turn that into an ordered categorical variable. If I want to create categories out of it, I can, but I can't take the categories and then turn that into a ratio variable. So always measure something at the highest level when you're given a choice. That's all I have for you today, and thank you very much.